Yeah, good evening. We will start the session in 5 minutes. Okay, within 5 minutes. So yeah, hello everyone. A very good evening. I hope I'm audible and visible. If not, any one of you can confirm it.
Your voice is very low, ma'am.
Okay, voice is now it's going.
Now better, ma'am.
Okay, just now it's audible properly.
Yeah, yeah.
Yeah.
Yes.
Okay, okay, okay. Thank you. Okay, so let's start the session. Uh, Hello everyone, my name is Pooja Verma and PMRF Research Scholar from IIT Kharagpur and instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering, IIT Kharagpur. This is a week 10 live and interactive session on computer vision. So I hope all of you have gone this week video lectures. So here directly we will solve some questions which will be very similar to your assignment question. So the course content for this week is clustering and classification. Okay, so let's solve the questions first, then we will discuss in detail also. So our first question is, what technique will you choose to discover various types of risk management of an activity? Option A is classification or option B clustering. So any idea, at least guess for this question? Any guesses? What technique will you choose to discover various types of risk management of an activity? So here they are asking about the risk management of an activity. So what about the risk management? So there are different types of risk are there, right? So how to manage them? So which type of classification or techniques will here we need to choose? So okay, let's see the detailed explanation here. So firstly, what is a clustering and classification? So already we know that clustering is an unsupervised machine learning technique that is used to group similar data points together. right? In the context of discovering various types of risk management, clustering would be applied to identify natural grouping or categories of the risk management approaches within a dataset without prior knowledge of the category. So this allow for the discovery of the different types of pattern of a risk management strategy that might exist within a activities dataset. And where classification, on the other hand, is a supervised learning technique. So what is unsupervised learning, machine learning and supervised machine learning? So in supervised machine learning, as we know that the data sets or classes are labeled. They are labeled data sets. That means we know which category belongs to a which data. Basically, we are labeling that data set. And in unsupervised learning, we don't know which category it belongs to. It is a randomly data has been given. Okay. So in the classification, here we are using the supervised machine learning techniques where the models is trained on the labeled data to categorize new data point into a predefined classes. While classification could be used to assign a specific risk management approach to known category, it wouldn't be a technique chosen to discover various types of risk management in the first place. So as that requires exploratory, so unsupervised approach like clustering. Okay, so best option is we will use the answer B, that is classification. No, clustering here because it will work on the unsupervised learning. There are different types of risk management. They are very unknown and unpredictable and in random state. So we don't know which type of risk belongs to a which data point. Okay, so best solution or answer B, that is a clustering. So this is a application specific question. This type of question may come, but on different application. So just you should know uh, about the, I mean, risk management category, which category it can be belonged. It is a very unpredictable random state or it is a predictable state. So based on that, you have to decide. Okay. Now moving to our next question. There are four well-separated spherical clusters, namely C1, C2, C3, and C4, in a dataset such that their centers appear at the four corners of a square of unit 1 in clockwise direction. We have changed position of cluster instances to vary homogeneity and separateness measured in the dataset. What happens if we decrease homogeneity of C1 and C2 and the separateness between the C1 and C2 largely? So here we are decreasing the homogeneity as well as separateness in between C1 and C2. Okay, so what will happen? They are asking. So option A is the dataset may appear as 8 clustered dataset. Option B, the dataset may appear as a 6 clustered dataset. Or option C, the dataset may appear as a 3 clustered dataset. Or option D, no effect. So here they have given that there are four clusters, namely C1, C2, C3, and C4, right? Four clusters are there. C1, C2, C3, and C4. Okay. Uh, Such that they send, okay, appears in the one square unit of one clockwise direction. Okay. So if we have changed position of the clusters every instances and to vary homogeneity and separateness. Okay, so if we decrease the homogeneity between the C1 and C2 as well as separateness C1 and C2 largely. So what will happen? Any idea? Would you like to answer this question? let's see the detailed solution for that. So let's see first what is a homogeneity and separateness. So homogeneity refers to how similar the data points within a cluster are to each other. That means within a cluster, how much they are similar within a cluster. And decreasing homogeneity of C1, C2 means the data points within these clusters become more diverse or spread out. Okay, they can become a more diverse or spread out. And the separateness or separation refers how distinct one cluster is from another. So how distinct they are. So decreasing separateness between C1 and C2 largely means that boundaries between C1 and C2 become less clear and the two clusters start to overlap significantly or even they can merge itself also. Okay, so that means within a cluster C1, let's see this is a C1, this is a cluster our C2, and there are other clusters also C3 and C4. So if we decrease the homogeneity between this in C1 cluster, so what will happen? That in the cluster C1, the data points become more diverse. That means they will spread out from from the middle point, and while the another one, so decreasing the separateness between the C1 C2, that means in this that means they largely that means boundaries between C1 and C2 become less clear. That boundaries will be maybe disappear or overlap in between these two. So if we decrease both these two, they may become a one cluster, right? If we just decrease these two things, so if C1 and C2 becomes less homogeneous and their separateness decreases significantly, they are likely to merge into a single larger, less distinct cluster. Since C1 and C3 and C4 are still well separated from each other, they are not affected because they are not said that if, between all the cluster they have just blended between C1 and C2. Okay, so in that case, if we decrease the homogeneity and separateness, then the cluster will be merged and become a one large cluster like this one. The original four clusters C1, C2, C3 and C4 would effectively reduce the three perceived clusters that the combined of one cluster C3 and C4. So the correct answer for this question, the data set may appear as a three clustered data set. Okay, the option C is the correct answer for this question. Okay. If we decrease the homogeneity and separateness between the any two cluster, that means if we decrease the homogeneity, that means the cluster become more diverse. They will start separating or going out from that within their cluster. And if we decrease the separateness, then our cluster or the boundaries may disappear and that will merge to another cluster. So that's why the four clusters become a three cluster by decreasing the homogeneity and separateness between the any two clusters. So the data set may appear as a three cluster data set. This one is a correct answer for this question. Okay. Okay. So I hope you have understand this question. So now moving to our next question. Okay. So now our next question is consider the following algorithm for the initialization in PAN. Consider the following. So PAN that is called also called number 3. So it is full from partitioning around matter. So here it is we are initializing that of the clustered centroid. So here our first point is consider an object I which has not yet been selected on our Second point it is here. Consider a non-selected object J and calculate the difference between its dissimilarity D minus C between with the most similar previous selected object and its dissimilarity dji with object I. If the difference is positive, object J will contribute to the decision. And next, to select object I, therefore we calculate by this equation Cji is equal to maximum dj minus dji comma 0. So our next, this is a algorithm for PAN. Okay, we have given. These are the processes we have to follow to solve this question. Okay. So now next one is a calculate the total gain obtained by selecting object I, that is summation of J, CGI, and choose the net yet selected object I, which maximize the CJ, summation of CJI. Okay. So this similarity matrix between the six families of a plant, we want to partition these data into two clustering using the PAN. So we have to use this data and partition this data into two clusters using PAN algorithm. So assume we have randomly chosen C, that means this one C, as a one of the representative. Calculate total gain if A, that means A, would be the another representative. Our first representative is C and our second representative is A. Now we have to use this dissimilarity matrix to calculate the num we want actually two partitions. So two partitions between these two data sets. So how we can forward? Already they have given the equations. By using these algorithm, we can just solve this problem. Okay, so let's solve the problem this one. Okay, so the formula for the gain contributed by a non-selected object J towards selecting a candidate method, let's see, I is, so you can write it here. The formula for the gain contributed by a non-selected object J towards selecting a candidate method I is, this is our formula CGI is equal to maximum dj minus dj small d j y 0. So where our dj is the dissimilarity of object j, and dji is the dissimilarity between j and candidate I. Between j and candidate I. Okay. And already we know that total gain is computed by summation of Cj I, that is it. Now already in the question given the selected method first, our first is C, and candidate next method, that is I, that is A, right? Now the non-selected object, what are the other non-selected objects are there? Non-selected object that is represented by J. So let's see, A and C has been selected, A and C. So non-selected objects will be B, B, D, E, F, right? A and C are the selected objects. That is, assume we have randomly chosen C and one of the representative and total gain A. Calculate total gain if A would be the another representative. So A and C are the selected object and B, D, E, F are the non-selected object. Okay, so B, D, E, and F are the non-selected object. Okay, now the provided dissimilarity matrix. We have to use the provided dissimilarity matrix. So in that dissimilarity matrix, first here I'm just writing we will use provided dissimilarity matrix. So in which that must be follow dxy must be equal to dyx. Okay, so now we will find out the dissimilarity, the dxy and all those things between the two objects. So how we can find out? So first we will find out. Let's I'm just writing here. It is a pair. Here I'm writing the pair between them from the, which from between these two pairs we are finding out the dissimilarity. Okay, so pair and dissimilarity. So first between the pair B and C. Here our first representative, that is a select majority C. So we have to find out the this similarity between C and every non-object which is not selected object, and then we have to find out the next our next representative is A. This is our selected. So between these two, so we need to find out the dissimilarity between the non-selected object. So first is our BC and it is dissimilarity represented by this small d. So how we can find out? So already dissimilarity matrix is given here, right? So how we can see that? I will let you know. So our B is this side and this is our C. Just reduce this one here so that we see the clear. Okay, so let's see. First, it is a B. I have written like D, B, comma C, right? So we have to see that this and already it is also equal to D, C, comma B, right? So if we see B in this row and see here there is a nothing, so we will see C, comma B. So what is the value? D, B, C, B, comma C. This is a 12, right? Now, similarly, we have to find out the other dissimilarity between C and other non-selected. So next object our let's see D, comma C, right? D, comma C. So our B, D, E, F are the non-selected objects. Just remember, we have to find out the dissimilarity between BC, CD, CE, CF. Then AB, AD, AE, and AF. Okay, because A and C are the already selected representative here. So now similarly we have to find out the dissimilarity between the D and C. Okay, so D is our D and C. Where it is a, it is a D and this one is a C, right? So this one 8. Similarly, we have to find out the D, comma E. Okay? No. E comma C, because one is selected. E comma C, right? So E and C. Our next dissimilarity is 19. Similarly, we have to find out the F comma C. So what will value? Can you tell me now? Just see and let me know what value will be there for this dissimilarity. F comma C. So F comma C. So this is it. Okay. So it is a 23. Similarly, we have to find out the between A and other non-selected object also. Just a minute, my pen is not working. So can you tell me now first B comma A? So what is the dissimilarity between the B comma A? So this is a B comma A. What is the value? This is a 7, right? This value 7. Similarly, we have to find D comma A, E comma A, and F comma A in the same way. So you will get 13, 16, 16, right? The first column values. So make a table, then just calculate this one. Then after that, we have to find out this capital D and J. Okay. Yeah. So I'm just directly writing in that table so that it will be easy. So D comma C, D, E comma C, D, F comma C. Then similarly for again B comma A, D, A comma plus C. This side is non-selected object. Yeah. So here D comma A, then D, E comma A, then next one is our D, F comma A. So values already I had told you in the previous slide how to calculate from the given dissimilarity matrix. So I'm just writing it here. So 12, 8, 19, 23, 7, 13, 16, 16. These values you can check. Okay. So already we have calculated this matrix. Now we will use these values. So to calculate dj, first point to calculate, that is dj, what j represents in our case, j is the dji, that is the dissimilarity between j and candidate matroid, that is I, right? And that dj is calculated by c is the only selected matroid. So we have to calculate for that first, since c is the only selected matroid. So dj is the j comma c. So j is the non-selected object. So what are the different dj? So these are the b, d, e, f, and for c, for the selected matroid c, they are specifically asking. So it is represented by dj. Okay. So non-select for non-selected object, object. So first one is a B, so it is represented dB, right? So dB is dB comma C, right? So what is the value? It is 12. Similarly for the D, D for D, so D capital D comma C, it is 8. Already we have calculated all these values, so just for calculating the final one, that's why we are taking it here. Now DD, DE, so D E comma C, that is 19, and D F is D F comma C, that is 23. Now we have to gain, calculate gain, that is CJI, it is given in the question for the non-selected object J. Again, selected object J. So how we are calculating CJI? CJI is equal to maximum, right? Dj minus Dj A. That means this is a J is written non-selected object or non-selected madroid, right? So it is representing Dj. These are the values, and this one is representing Dj comma A. That means the another representative. Okay, we have selected the two representatives C and A. This is corresponding to A, C, first representative, and this is corresponding to the another representative A. Okay, maximum of that comma 0, right? Now that means we can call it C, B, A first. Okay, J, that means non-selected object. I already we have seen in the previous slide, that is A, that means selected madroid. Okay, so it is maximum here, so dB minus dB comma A 0. Okay, so just put all these values already we have calculated here. So our dB is 12, right? 12, and dBA here it is a 7 comma 0. So here you will get maximum of 5 comma 0. What is our maximum value? So 5. So CVA we have got, that is equal to 5. Okay, now we have to calculate the other non-selected object also, that is a DEA, DEF. Similarly in that way. So I am just okay, I'm taking the another slide so that okay. So take another non-selected object first, C, DA. So put in that formula, that is maximum of DD minus DA comma 0. So now put the value, you will get maximum of 8 minus 13, actually 8 minus 13 comma 0. So here you will get maximum of minus 5 comma 0. So maximum value is 0 because it is in minus 5. Similarly, we have to calculate C, E, A. So that is maximum of DE minus E comma A. Now put the values. DE is, the value is 19 minus 16 comma 0. So here you will get maximum of 3 comma 0. So maximum value is 3, so 3, right? CFA. Similarly, we have to calculate maximum of Bf minus Bf comma A comma 0. Okay. So here you will get maximum of 23 minus 16 comma 0. So here you will get maximum of 7 comma 0. So maximum value is 7. So 7. Now to calculate the total gain, already we know that it is given in the question. This is a summation of a CGI. So all these values are the CGI. These values are the CGI. So first we have got 5. So just it is the summation of 5 plus 0 plus 3 plus 7. So we will get 15. Okay. So this is our answer 15. If you see in the answers, so you will get option B is the correct answer for this question. Okay. Okay. So I hope all of you have understand this question. So now moving to our next question. Already detailed solution I have given here. You can see it in the later when I upload this slide. Okay. Now our next question is, assume there are 6 different people from various states. We want to identify the mother tongue of a new person X. Okay. Given the distances between two states they are born. Also, mother tongue of those people are given in a symbolic nation in the following table. So it is given. So distance from the new person X, it is given A, B, C, D. These are the other person, and this one is their mother tongue. Okay. So can you determine what is the mother tongue of X using KNN classifier where K is 3? So can we find out it? Any one of you can suggest how to move further? Okay, so the KNN algorithm classify a new data point that is a person X by finding its nearest neighbor and assigning its class that is a mother tongue that is the most frequent among those neighbors. Okay, so already here this table is given. Now, so this is since k is equal to 3. So to find out the 3 people with the smallest distance from x. Okay, so let's make one table here itself. Okay, so first we will rank that person that we will do later, which is nearest or which is farthest. So person here distance from x, let's say from x and their mother tongue assign. Okay, so first that is a person. We are just doing in ascending order, no descending order. Okay, with this distance from x first. So what is our lowest one? This one is 5, right? And this corresponds to a person f, right? So just arrange this one, then 10. This belongs to a. Now next one is c. This belongs. This is 20. Now next one is a 40. This belongs to B. Now next one is E, that is 70, and B, right? This one is 100. And just assign their mother tongue as well. So this is for 1, First one. The second one, 10, is also a 1. The third one, that is 20, it belongs to another term 2. 70, this is belongs to 4. Then 100 is also 4. Right? So what are the different nearest one from the distance from x? So these three, 1, 1 and 2, right? For k is equal to 3, the nearest neighbor ours, that is f, a and c. And if you assign their mother tongue, so they this belongs to one mother tongue 1, and this one is also mother tongue 1, and this belongs to a mother tongue 2, right? So from mother tongue 1, these two, so this has a highest frequency or highest co-occurrence. The number of count is more for mother tongue 1, right? So the majority mother tongue among the majority mother tongue among k is equal to 3, for k is equal to 3, nearest neighbor is 1, is 1. So what the mother tongue will be? So mother tongue for x is will be 1 only. So mother tongue for x is 1 because for k is equal to 3. So f and c, that they are the nearest and their mother tongue is 1. So this is occurring the 2 times. So the frequency of co-occurrence is more. So that's why mother tongue is more relative. Mother tongue 1 is more relatable to the new person x. So for new person x, the KNN algorithm find mother tongue 1 will be the more efficient. Okay. So here option A is the correct answer for this question. Okay. Okay. So I hope. So have you understand this question how to solve? So ranking is based on the distance. So F is ranked 1 because it has the lowest distance from X, and similarly for A it is 2, for C it is 3, 4, 5 and 6. Okay, this is so it is not required. You can just calculate the which have a highest frequency, that would be a selected. Okay, and a detailed solution also I have added in this slide, so you can see in the later. Okay, so have you understand this question? Can we move to the next question? Okay, so I hope all of you have understand. So now moving to the next question. Now our next question is, assume you want to design a classifier which will process 100 16 cross 16 images. Each image contains only one digit. You are probably using multi-layer perceptron. How many inputs and output neurons will be in the multi-layer perceptron for this problem? So how many input and output neurons will be there for this one? So they are asking, we are designing a classifier which will process 100 16 cross 16 images. Okay, we need to process a 16 cross 16 100 images. Okay, and each image contains only a one digit, and that each image, that means that 100 images will represent the one digit only. That means that one digit will vary 0 to 9, right? So we have to use the multi-layer perceptron. How many inputs and output neurons will be there in the multi-layer perceptron for this problem? So there, that means input is we have to process that 100 images that have 16 cross 16. So what will be the, we have total number of how many, that means that represents the input. So how many input will be there? So how many images are there? 16 cross 16. That will be 256, right? 256, 16 cross 16. And this is the input of our perceptron input, and that they have given each image contains only one digit, and that one digit contains 0 to 9 only. So total that will represent the 10 outputs. That means we have to present in the 0 to 9. That means that should represent in the form of 0 to 9 only. So that means 10 outputs will be there. Okay, so here already detailed solution here. So input neurons, each image is 16 cross 16 pixels. So in a multi-layer perceptron, each pixel typically corresponds to one neurons, and therefore the number of input neurons will be there. Total number of pixels in one image is 16 cross 16, and we have to process this 100 16 cross 16 images. Okay, so output neurons, the classifier task to identify single digit in each image. So since there are 10 possible digits, so 0 to 9, because we have to put in the single digit. So output layer of the MLP will need only 10 neurons that will represent in a single digit. So each representing the probably image of being particular digit. The total input will be the 256 and output is 10 will be there. So option B is the correct answer for this question. Input is 256 and output will be the 10, because we have to represent it only in one digit. Okay, so have you understand this question? Can we move to the next question? Okay, so no one is answering. So moving to the next question. Now our next question is, assume you have a perceptron with two inputs, each with weight 3 and overall bias of 4. Can you say which logical function this perceptron computes? So how we can solve? So we have a perceptron with two inputs and weight is also given and overall bias is given. Now we have to compute that perceptron and find out which logical function it belongs to. Okay, so a perceptron is a, already we know that a perceptron computes the weighted sum of its inputs added bias and applies on an activation function. So to determine its output. Okay, so in this case we have two inputs. Let's say input is x1 and x2, and with their weights, that is w1. Let input is x1 and x2, and their corresponding weights are w1 and w2. That is equal to 3. It is given each with weight 3, and overall bias is also given is 4. Right. So the formula for the output of the perceptron is W1 x1 plus W2 x2 plus B, that is a bias, okay, is greater than equal to 0, then output will be 1. If it is less than 0, then output will be 0. Okay, if this is our perceptron rules. So the given condition of the output become 1 will be the if this function should be greater than or equal to 0. So here input is given because weight is given. So just put in this equation and try to find out. So here this equation you will get 3x1 plus 3x2 plus 4 must be equal to 0 for output should be 1. Y is equal to 1, right? So this criteria must be followed. Now we don't know inputs here. So for any logic function that is AND or and NOR and AND gate, already we know that there are four input combinations are there 0 0 0 1 0 1 0 and 1 1. Just check for the all the input combination. Compute for all input combinations. So for 0 comma 0 so the input that means x1 and x2 both are 0. So just put it in this equation. So x1 and x2 are 0. So 3 into 0 plus 3 into 0 plus 4 that is equal to 4, right? And this is greater than equal to 0. So here output will be 1, right? Because it is greater than 0. Similarly, we have to calculate for 0 1, right? And then y is equal to 3 into 0 plus 3 into 1 plus 4. So here y is equal to 7 you will get which is greater than equal to 0. So our final output will be 1 only here also. Similarly for 1 0 also you will get 7 which is greater than 0. So for this one is also y is equal to 1, right? Now we need to find out for case 1 1. So y is equal to 3 into 1 plus 3 into 1 plus 4. So here you will get 10 which is also greater than equal to 0. So here you again you will get that means in all the input all the cases input combination you are getting for all the input combination. Can take another slide. Okay, just I'm writing here. I'm removing it here. I hope all of you have noted down. So for all input combinations you are getting y is equal to 1, right? So this perceptron is giving the output 1 regardless of the input. So none of the options are matching because the if you see the truth table for the AND or NOR and NAND gate. So here you are getting actually x1, x2, y. Let's I'm making 0, 0, 0, 1, 1, 0 and 1, 1. You are getting all the input output high in all the cases all we have checked but none of the combination or logic function give all the always high output. So if you check just and removing it from here, okay. So if we check the truth table for AND or and not gate, so I'm just inputs and giving so 0 0 0 1 1 0 and 1 1. So for AND gate already we know that what will be the our output here 0 0 0 1 you will get. For OR gate you will get 0 1 1 and 1. For NOR gate just opposite of OR gate that is 1 0 0 0. Similarly for NAND gate here you will get 1 1 1 0. So none of the truth table of this matching. So here actually the incorrect options are there. So for this question you will get none of the above or if this is the incorrect question. So none of the above if there is option the above above is matching. Okay. So this is the one is correct. So here no there is a incorrect options are given. So in the exam, that type of question you may get if there is nothing matching, because already we have solved step by step, so none of the options are matching.
Excuse
With
me.
this, yes,
But in given options, there is no none of the option, right?
yes, what you are saying? Yeah. You can just, yeah,
You
you can.
don't have to choose, right?
Yeah, you don't need to choose here. If there is option to writing somewhere, so in the exam you will get some other options also.
Okay, okay. Thank you.
Okay. Yeah. Okay. So I hope all of you have understand this question. Now we will move to our next question. So our next question is, assume a game where a person can invest X dummy coins and Y rewards according to the investment. Consider A and B are two players who have invested 6 and 3 dummy coins. Will you classify two players into the same class based on the reward collected? You may use linear discriminant analysis, that is LDA, where the function is given as. So for LDA, the function is given as a f of x is equal to minus 4 by 3x plus 5. So here we have two players A and B, and they have invested the 6 and 3 dummy coins. Okay, so here it is also it did. So now we have to determine if players are belongs to the same class based on the rewards. We need to to determine if players belong to the same class based on reward they have got based on rewards. So first we will calculate for player 1, sorry, player A, that's it. So player A has has invested 6 dummy coins. That means x is equal to 6 dummy coins, right? So just so here the function is given. So x is equal to 6. So calculate for f6. So minus 4 by 3 to 6 plus 5. So this is the reward, that is f of 6. So here you will get minus 8 plus 5. So that is the score for player A is minus 3. Okay. Now similarly we need to calculate for player B also. So player B has invested 3 dummy coins, right? That is 3 dummy coins. It is given here. Player A, two players have invested 6 and 3 dummy coins. So here you will get f is equal to 3 minus 4 by 3 into 3 plus 5. Okay. So here you will get minus 4 plus 5. Here the reward for player B is 1. And the reward for player B is minus 3. So players A reward is minus 3. Player B reward is minus 1. Since these two rewards are different, so that means the player could not be classified into the same class based on the rewards collected. So their rewards are are different. So, so they will not classified in the same class. So that means answer is B. That means they are not classified in the same class based on the rewards they have collected. Okay. So option B is the correct option. Okay. So have you understand? If this type of question will come, you will able to solve this. Okay. Okay. So I hope you have understand. So now moving to our next question. So our next question is, consider the following table. The table shows the points on x-axis and its corresponding class. So here table 1 is given, their points and class is also given. So now we introduce two new points on the x-axis in that axis, that is 3.7 and 4.2. Now we have to compute k and n. K is equal to 3 to determine their class. So for the 3.7 and 4.2, what class they will belong. Okay. Now we have to just calculate that one using k and n, and where k is given as a 3, right? So how we can calculate this one? Okay, so let's calculate. Already we have solved one question based on that. Okay, so determine the three nearest neighbor for point 3.7 and similarly for point 4.2 also. So for that we need to calculate the absolute difference here to find the nearest neighbor. To calculate the nearest neighbor, we need to calculate the absolute difference between the points differences. Okay, so first we will calculate for 3.7. Okay, so just we need to calculate for each from each point. So point is given, class is given. So let's calculate here. So first make a point, class, and absolute difference differences for 3.7. Yeah, are you able to listen me? I'm audible, right? Okay, so first point is 2.5, 3.5, 4, 5, and 5.5, and their corresponding class is 1, 2, 1, 2, and 2. Okay, so from the first point, so 3.7 minus 2.5, their absolute difference, you will get 1.7. Similarly, calculate for the next point, 3.7 minus 3.5. So here you will get 0.2, right? Here for the third point, 3.7 minus 4, you will get 0.3. For the 3.7 minus 5, you will get 1.3. For 3.7 minus 5.5, you will get here, actually difference you will get 1.8. Okay, so what are the nearest neighbors? So that means which have a minimum distance, absolute difference. So which have a, so this one has a minimum. We have to choose for k is equal to 3, right? So this one, and another one, this one. These have a minimum differences. So these are the three nearest neighbors, right? So the three nearest neighbors are, that is point 3.5, 4, and 5, right? No, I think 0.2. Here you will get 1.2, not a 7. Okay, so there is a mistake. Just a minute. So 1.2. That means 3.5, 4, and 2.5 are the nearest neighbor. And 3.5 belongs to which class? That is 2, 1, and 1. So this is belongs to a class 2. This belongs to class 1, and this one is also class 1. So which have a highest occurrence? Here class 1 has a majority voting. Here class 1 has majority voting, that is 2 votes are there. So the point 3.7 belongs to class 1. Okay, that means the point 3.7 belongs to class 1. Similarly, we need to find out the class for 4.2 also. Okay, so guys, it is little bit hanging. So if any problem will occur in future, so I will just wait for some more time. I will rejoin. Okay, I will complete that class. Okay, so similarly, we have to compute for 4.2 as well. Okay, so again, we have to make that one point class and absolute differences. So points are 2.5, 3.5, 4, 5, and 5.5. And this belongs to class 1, 2, 1, 2, and 2. Again, find out the absolute difference between these points. 4.2 minus 2.5, we will get 1.7. 4.2 minus, sorry, yeah, correct. 3.5, you will get here 0.7. Here you will get 4.2 minus 4, you will get 0.2. Here you will get 4.2 minus 5. Here you will get 0.8. And for this one, 4.2 minus 5.5, you will get the absolute difference 1.3. So what are the minimum distance? Minimum distances are there. That is 0.2, 0.7, and 0.8. Right? So the nearest neighbor will be nearest neighbors are, that is 3.5, 4, and 5. So 3.5 belongs to a class 2, 4 belongs to class 1, and 5 here belongs to a class 2. So here class 2 has a majority voting. majority voting, right? So that means point 4.2 belongs to class 2. So in the summary, you can write it point 3.7 belongs to class 1 and point 4.2 belongs to class 2. So this is our final answer, right? So let's check from the options. So from the option, you can see 3.7 belongs to class 1 and 4.2 belongs to class 2. Okay. So option B is the correct answer for this question. Okay. Okay. So I hope you have understand this question. Is there any doubt? Can we move to the next question? Okay. So I hope all of you have understand this question. Okay. So our next question is, assume you have five types of objects, that is A, B, C, D, E, and with three attributes, attribute 1, 2, and 3. Each as shown in the table. Consider object A and object C as the initial centroid, that means this one and this one. What will be the element in each cluster after the first iteration? So what will be the elements in each cluster after the first iteration? Okay, so here we have five objects and three attributes. Now A and C objects are, they have said assume they are the initial centroid. Now we have to calculate what after first iteration, what will be the cluster elements there. Okay, so let's see the detailed solution for this one. Already I have just put it down. So for key means clustering, first after first iteration, here the perform. So for first step one, we need to calculate equilibrium distance from the each object to the centroid A. So already they have told we have to take the centroid A and C and their points. So for A, these are the 1, 1, 1. So that's why we have taken 1, 1, 1. For C, there is a 5, 3, 2. Right? So that's why we have taken centroid 5, 3, 2. So now we have to calculate the Euclidean distance for each object. So already we know that Euclidean distance is from the each object. First, we are finding the A distance between A and A. We have to find the distance for each object A and A, then AB, then AC, AD, AE, similarly for CA, CB, CC, CD, and CE. Okay, so just they have calculated for each point. So 1 minus 1 square plus 1, so you will get 0 here. Similarly for VA, we have to calculate here. We have taken the centroid A first, then C. So for B, the points are 2, 1, 2. So that will be the 2 minus 1, 1 minus 1, and 2 minus 1, all the whole square. So here you will get in this one 2 minus 1, 1 square plus 0 square plus 1 square. So here 1 plus 0 plus 1, you will get 2. Okay, similarly for the distance, calculate distance from C and A. So C points are 5, 3, 2, right? So we have to calculate C and A. So point in A is 1, 1, 1 and point in C is 5, 3, 2. So 5 minus 1 square, 3 minus 1 square and 2 minus 1 square. So here you will get 4 square plus 2 square plus 1 square. So overall you will get 16 plus 4 plus 1. So if you add this, you will get 21. So this is our distance between C and A. Similarly, we have to calculate distance from DA and EA. So what is the values for the DA? 440 and E is 313. Right? Here we can write here distances 440, 3, 1 and 3. Right? So just calculate 4 minus 1, that is 3 square. Again 4 minus 1 is 3 square. 0 minus 1 square. So 1 square, you can say that. 9 plus 9 plus 1. So you will get here 19 is our answer. Similarly for EA, so here you will get 3 minus 1 square plus 1 minus 1 square, and so here you will get 2 square, 0 square plus 2 square. So here you will get 4 plus 0 plus 4. So overall you will get 8. Right? So this we have calculated the Euclidean distance from each object to centroid A. Similarly, we have to calculate for the Euclidean distance from each object to the centroid C for the first equation. So we need to calculate the distance between AC first, right? So C point is given 532. Okay, so just 1 minus 5, so that is minus 4 square plus minus 2 square plus minus 1 square. So if you just cast 16 plus 4 plus 1, so you will get 21. So 21 again from the BC, C is 532, and already we have seen that in the B we have 2, 1 and 2, right? 2, 1 and 2. Similarly for C point is 532, already we know that D is already here we have written all the points. Similarly we have to calculate here minus 3 square plus minus 2 square plus 0. So 9 plus 4. So 13. This one is for between C and C, you will get always 0 because the 5, 3 minus 5, 3 minus 3, 2 minus 2. Similarly, we have to calculate DC. So 4 minus 5, that is minus 1 square minus 2 square. So here you will get 1 plus 4. So 6 you will get. Similarly for this one also, our E point is 313, right? So 3 minus 5 square, so minus 2 square plus minus again 2 square plus 1 square. So here you will get 4 plus 4 plus 1. So here you will get 9. Okay, so this is for the step 1, and step 2. Calculate the distances from the each object to the center, the selected centroid A and C. Now next step, to assign the object to the nearest centroid. Okay, whose centroid is closer, who has a smallest distance. Okay, for object A, distance is AA is 0. We have calculated here, right? And distance from AC, that is 21. We have calculated here from AC. So A is closer to the centroid A because centroid has a 1 attribute. It is a closer to A, this distance. So A is closer to the centroid A. Similarly, we have to decide for the object B also. So BA for the this one we have got 2, and distance from BC from the A and C 13. So which one is closer? So B, this one is closer because 1 is closer to the centroid A. Similarly, we have to see about distance CA and CC. So here 21 we have got, that C is equal to 0. So C is closer to the centroid C. So this point is, so it belongs to the centroid C. Similarly for DA, it is 19, 6. So D, the 6 is smaller. So this is closer to the centroid C. Similarly for EA, 8. Here we have got 9. So E is closer. So 8 is lesser. So that means this is closer to the centroid A. So now we have to make each cluster of the first iteration. So cluster 1, in cluster 1, that is the smallest distance between the from the A. So this is A, B, and E because the A has been assigned to A, B, and E, and for cluster 2, it belongs to the another because it is nearest to the centroid C. So cluster 2 is C and D. So we have two cluster 1 A, B, E, and cluster 2 is C and D. Okay, so cluster 1 is A, B, E. So option A is the correct answer for this question. Okay. Okay, so have you understand this question? Any doubt? Anything? I hope there is no doubt. So no one is answering. So yeah. Moving to our next question. Okay, so our next question is the output of a neural network is 24715. Find the softmax probability for 7. Answer to 4 places of the decimal. So correct answer already given. Now how we can solve this question? The output of the neural network is given, that is 24715, and find out the softmax probability for 7. This one. So how we can find out the softmax probability? So the softmax probability is calculated by this equation, that is E Z I E of Zi divided by summation e to the power Zi, where J. So here Zi our Z, we have to find out for the 7. So here our Zi is equal to 7. Okay. So that means we have to find out the probability for 7. So here e to the power 7. Here it is a summation of all the output. Okay. So that means e to the power 2 plus e to the power 7, 4 e to the power 7 plus e to the power 1 plus e to the power 5. Now just take your calculator and calculate these values for e to the power 7, e to the power 2, 4, e4, e7, e1, and e5. So already I have calculated. You can calculate later also, otherwise you can calculate. Okay, just waiting for few seconds or 1 minute so that you can calculate these values. Then I will write it here. Okay, just try to calculate. Take your calculator and calculate these values. Yeah, answer is 0.83. Yeah, okay. You have calculated which values. Answer is already given here. Okay, so let's see what is our value for E7. So if you calculate in the calculator, you will get the value 1096.6332. Okay, for e to the power 7. Similarly, if you calculate for e to the power 2, you will get 7.3891 here, plus for e to the power 4, you will get 54.5982. For e to the power 7, already we have calculated 1096.6332, plus e to the power 1, we will calculate, we will get 2.7183. Now plus e to the power 5, we will get 148.4132. Okay, if you just 1096.6332, if you add all these values, you will get here 1309.7520. And if you just divide it, you will get 0.837380, and which is answer. So they have asked answer the four decimal places. So just 0.8373 are the value. Okay. Okay. So this is it for question 10. I hope all of you have understand this question. So now let's move to our next question. So our next question is, assume you want to cluster 7 observations into 3 clusters using k-mean clustering algorithm. After first iteration, C1, C2, C3 has the following observation. That means C1 is 2, 2, C2 is 4, 4, and in 6, 6. In C2, there is 2.0440, and for C3, it's 5599. What will be the cluster centroids if you want to proceed for the second iteration? So to proceed for the second iteration, we have to calculate the cluster centroids. So already it is our after the first iteration. Now we need to calculate the centroid of these clusters. So how we can calculate this one? Okay, so these are the C1, C2 and C3 are the given clusters after first iteration, right? So centroid of the data points in cluster, we have to calculate the centroid for the cluster C1, C2 and C3. Centroid for cluster C1. So how we can calculate for the centroid in the cluster? So just we have to take these points and take the average mean of this, the first and the second point. So here it is 2, 4 and 6, right? So 2 plus 4 plus 6, there are 3 points, so 3. Again it is the same, 2, 4 plus 6 divided by 3. So here you just calculate it, you will get 12 by 3 and 12 by 3. So here you will get 4 comma 4 for the cluster C1. So centroid for the cluster C1 we have got 4 comma 4, and similarly we have to calculate centroid for cluster C2, right? So here 2 points are there, 0, 4 and 4, 0. So 0 plus 4 divided by 2 and 4 plus 0 divided by 2. So you will get here 4 by 2 and 4 by 2. So here you will get 2 and 2. So centroid for the cluster C2, here you will get 2 comma 2. Similarly, we have to calculate for the centroid for the cluster C3. So just I'm doing it here. I hope all of you have noted down.
A is correct option.
A is, yeah, A is the correct option. So let's calculate for the centroid, for the cluster centroid, for cluster C3. So there are 2 points. So for C3, here again 5 plus 9 divided by 2. 5 plus 9 divided by 2. So here you will get 14 divided by 2 and 14 divided by 2. So here you will get 7 and 7. So for C3, it is a 7 comma 7. So option A is the matching, that is 4 4, 3 2 2 and 3 3 for C3. So option A is best matching with this question with the answers. So option A is our correct answer for this question. Okay, so already you have understand this question. So now moving to our next question. The next question is calculate cosine similarity between 7482 and 321, 5 and 1. Okay, is it 21? Okay. So how we can calculate the cosine similarity between these 2 points? So to find out the cosine similarity between these 2 points, the formula is this comma A into B divided by mod of A and mod of B. This is our formula. Okay, so two data points are given, two vectors, that means A and B are given. So first we need to find out A dot B, then we will put. So just this is a dot product between these two vectors. So A is our 7 4 8 2 and B is our 3 21 5 and 1, right? So now calculate it. So 7 into 3 plus 4 into 21 plus 8 into 5 plus 2 into 1. So can you calculate it? So this is a 21, right? 7 into 3 and here it is a sorry, 8 and 4 plus 30 plus 10. So if you just calculate all these values, so you will get 30 plus 40. Okay. So actually I have miscalculated, but I have solved it. So can you just
Madam, 80 to 540, ma'am.
yes, 82.
You have placed 30 there.
Oh, okay. Yeah, it is 40. Yeah, correct. And here it is 2. 2 into 1. Yeah. So here it is 2. 7 into 3, 4 into 21, 8 into 5 and 2 into 1. Yeah, correct. Now, so 21 plus 84 plus 40 plus 2. So overall value you will get 147, right? Is it correct? So now we need to find the mod of this one. So already we know that it is calculated by square root of these values. So 7 square plus 4 square plus 8 square plus 2 square, right? So here you will get 49, 16 plus 64 plus 4, right? So if you add all these values, so you will get 133. root of 133. So here you will get 11.532. Right? Is it correct? Yeah. Similarly, we need to find out for B also. So here you will get 3 square plus 21 square plus 5 square plus 1 square. So here you will get 9 plus 21 whole square. What you will get? 441, right? Plus 25 plus 1. So how much you will get? Root of 476, right? So here the value you will get 21.817, right? So now find out the similarity, put all these values in this equation. So just I'm removing it from here. So here just put the values. Here it is a 147 and here we have got 11.532 into 21.817, right? So just calculate it. So if you just calculate, multiply these two values, so you will get 251.598, right? So 147 divided by 251.598. So you will get total 0.5842. Okay. So which option is matching? So this is our final answer. So it is matching with the
Option A,
option
ma'am.
A. Yeah. So option A is the correct answer for this question. Okay. So okay, this question has been done. So now moving to our next question. So our next question is a single layer perceptron with a step activation function, where it is given, is fundamentally limited in a type of the function it can learn. Which of the following is an example of a logical function that cannot be computed by a single layer perceptron? So which logical function cannot be computed by a single layer perceptron? So as we already don't know that already I told. So the rules for the perceptron criteria, this the criteria is x1 w1 plus x2 w2 plus b should be equal to greater than 0. Then our output will be 1. So I can write it here for y is equal to 1 and it will be less than 0. So output will you will get 0, right? So x1 and x2 are the inputs and W1 and W2 are the weights, corresponding weight. And this is our bias, right? So how we can solve? Just take the different input combinations, because here two input. So take the different input combinations and check input and combination. So what are the our different input combination? That is 0 0, right? 0 1
0 0 0 1 1 0 1 1.
1 1. So if you put in this one, so you will get B only, right? And for this you will get W2 plus B. For this one you will get W1 plus B, and for this one you will get W1 plus W2 plus B, right? So which logical function that cannot be compared by a single layer perceptron? Okay, so these are the functions that we have got, right? Now we have to choose weight also. So let's see, the details were already given. So a single layer perceptron that can be learned linearly separable function. That should be a linearly separable function. A function is linearly separable if a single straight line, that is, here if we have some points there, that should be a linearly separable. A straight line, if it is a straight line or a hyperplane in the higher dimension, can be drawn but to a separate data points belonging to the one class, that is output 1, from the data points belonging to other class, that is output 0. Already told you y1, y is equal to 1 if that function is greater than equal to 0, and y is equal to 0 if it is a less than, that is output 0 less than 0. Okay. So AND, OR, and NAND gate, these three functions are linearly separable and can be computed by a single perceptron. For example, the OR function's points can be separated by a line. We will see. I have one question based on AND OR this gate, so we will see that one. And XOR, this function is not a linearly separable. So if you see the logical function AND OR NOT gate, so already we know that for OR gate it is A plus B, for AND gate it is A into B, and for NAND gate it is A dot B dash. And for OR gate we have A dash B plus A B dash, right? So their output is non-linear. So 1 is 0, 1, 1, 0, right? So this function is not a linearly separable. The inputs 0, 0 and 1, 0 both are 0, both output is 0, and while 0, 1 and 1, 0 both output is 1 for the XOR gate. If the inputs are different, output that will produce the different output, right? So these four points cannot be divided into their respective classes by a straight line. So the inability to single perceptron to solve XOR problem was a major historical, it is a limitation, which was overcome by introducing multi-layer perceptrons with the hidden layer. Okay, so we have to increase the different more hidden layer for to execute the performance of the XOR gate. So option C, XOR gate is a not a linearly separable. Okay, so single layer perceptron is limited by a XOR gate. Okay, and these three are the linearly separable point. Okay, so option C is the correct answer for this question. Okay, so now moving to our next question. Yeah, next question is based on that itself. So weight W1 is equal to 2 and W2 is equal to 2. Both are the same. And bias B is equal to minus 3. It is given. Which logical function does this perceptron implement? Okay, so already we had seen that function already, so I can write it here again. Okay, so already we know that x1 w1 plus x2 w2 plus b should be equal to greater than 0 for output should be equal to 1. If it is less than 0, so y is equal to 0. So here already W1 and W2 is given. So here it is a 2x1 plus 2x2 minus 3. If you put the weights and biases in this equation, it should be greater than equal to 0 for to generate output 1, right? So let's see first which what is it is generating. So take a different input combinations, check for different input combinations that is 0 0. So if you take the input 0 0, so here you will get 0 plus 0 minus 3. Here you will get minus 3, which is less than 0, 0, right? So here it will produce output 0, right? Similarly for 0 1, so here you will get 0 plus 2 minus 3. It is also minus 1. It is less than equal to 0. Sorry, less than 0. So here again it will produce a 0 output. For 1 0, again here you will get 2 plus 0 minus 3. So again here minus 1. Less than 0. So here again you will get output 0. Right? Now for 1 1, so here you will get 2 plus 2 minus 3. So here you will get 4 minus 3, which is 1. So 1 is greater than equal to 0. So here you will get final output 0. So for the input combination, this one output you have got x1, x2, let's say 0, 0, 0, 1. So it is which gate truth table? Can you tell me? It is belongs to which gate truth table? Which logical function? It belongs to AND gate, right?
And gate, ma'am, and gate.
Yeah. So it is similar to AND gate truth table.
Yes.
AND gate truth table. So correct answer is AND gate, right? So it implements the AND gate. So option B is the correct answer for this question. Okay. So have you understand if there is gates are and similarly you can check for the different weights and biases combination for OR gate and NAND gate and NOR gate that is possible. So if this type of questions are given, so just put all these values and just check for the different outputs and compare with the corresponding logical function truth table and just get the final answer. Okay. Okay. So I hope all of you understand. So now moving to our next question. So our next question is for weights W1 and W2 both are 1 is given. What range of bias B? Choose the option will make the perceptron implement OR gate. So now we have to here implement the OR gate which is using greater than 0 threshold rule. So already we know that if it is a perceptron criteria, x1 W1 plus x2 W2 plus p should be greater than equal to 0 for output is equal to 1 and otherwise y is equal to 0, right? So here w1 and w2 is given 1, so w1 is equal to w2 is equal to 1, right? Now we have to check range for bias. So here what is our perceptron criteria will look like? So here x1 plus x2 plus b, right, should be greater than 0. It is given using the threshold rule 0. So they have asked perceptron implement OR gate. So just check for the different input combinations. Again, different input combinations For 0, 0, you will get B only. So B. So this B should be greater than 0, right? For OR gate. So now let's just check for the 0, 1. So here you will get x2 plus b, right? No, it is 1 plus b. So x2 not. Here we have taken 0, 1. So here x2, that means 1 plus b. Similarly, for 1, 0 also, it will produce answer 1 plus b should be greater than equal to 0. So here what combination we will get? B should be greater than equal to minus 1, right? For both the cases. Similarly, for 1, 1, you will get 1 plus 1 plus b. That means 2 plus b should be greater than equal to 0. And for the combination, b should be greater than equal to minus 2, right? So here minus 1 and minus 2. So that minus 2, minus 1 will be automatically come before the minus, minus 2 come after minus 1, right? So it automatically satisfy if b is greater than minus 1, right? B is greater than minus 1. So here the range of b is vary from 0 to minus 1, right? So the range of b is minus 1 should be equal to 0 to 1. Okay, so this range will the for b will vary to implement the OR gate, logical function OR gate. Okay, equal to here we can put. So here because b is equal to 0, we can take. So option B is the correct option. So any b in the range of this interval 0 to minus 1 will implement the OR gate. Okay. Any range between 0 to minus 1 will implement the OR gate. Okay. So have you understand this question? It is simple based on that only.
Yes, ma'am.
Okay. Okay. So now moving to our next question. The next question is, which is the most accurate conceptual statement about choosing K in KNN? Option A is a small k, example k is equal to 1, increases bias and lower variance. Option B, large k reduce both bias and variance. A small k leads to low bias but high variance, overfitting that leads to overfitting. And option D is k choice has no effect on bias and bias variance. So which is the most accurate conceptual statement about k means strings, that is k and n? About choosing k in the KNN. So k should be small or k should be large. Any guesses for this question? Okay, so let's see the detailed solution. So solution is if k is equal to 1 fits training data exactly, that means low bias, but it is sensitive to noise and new data point. So it will lead to a high value. And if k is large, so k is smooth on the decision boundary that leads to a higher bias and reduces variance. For small k leads to a overfitting and large k leads to a underfitting. So small k leads to a low bias but high variance, that is overfitting. Okay, so option C is the correct answer. That is the correct conceptual and most accurate conceptual statement. So small k leads to low bias but high variance, that is overfitting. Okay, so this is it. most correct and accurate statement for this question. Okay, so now moving to our next question. In KNN, what is the main effect of having an outlier training point far away from the majority of its classes? Option A, it always changes decision boundaries significantly. Option B, it only affects predictions in its local neighborhood. Option C, it has no effect on a classifier. Or option D, it makes KNN equivalent to linear regression. Which option is correct one for this question? In KNN, what is the main effect of having an outliers training point far away from the majority of its classes? Okay, so let's see the detailed solution is given here. So KNN basically assign labels based on its nearest neighbors, right? We have solved the many questions on that. So an outliers far away from the cluster of its class create a small region around itself where test points may wrongly classified. So it does not change the global decision boundaries significantly, but the effect of an outliers is localized, not widespread. So correct answer for this question will be it only affects predictions on its local neighborhood. Okay. Option B. It does not change the decision boundaries and does not affect the classifier. So option B is the correct answer for this question. It only affects prediction in its local neighborhood. Okay. So now moving to our next question. What are the necessary initial parameters required by k-mean clustering? So what are the necessary initial parameters required by k-means clustering? Option A, number of clusters. Option B, threshold on distances to put them in same cluster. Option C, initial cluster centroid. Option D, no initial parameters required. So at least answer for this question, what are the initial parameters required for the k-mean clustering? Okay, no interest giving the answers. Okay, let's see the detailed solution.
Option B, ma'am.
Oh, okay, threshold on distances to put them in the same cluster. Okay, it may be, but basically we need an initial cluster centroids. Already you see that when we are just we have solved one question also to find out the centroid, and number of clusters also defined. What are the like different classes are given na? In two three questions. In one question we have defined the one or two different mother tongues or this clusters are belongs to that classes also. Okay, so basically number of clusters and initial cluster centroid. These are the initial parameters. Okay, so detailed solution already I have given here. So number of clusters, that is k. So this is mandatory. K means needs to know how many clusters it should be partitioned into that data. So without k, the algorithm cannot even start. And initial cluster centroid. Another one is, so k means require the initial guess for the centroid. So usually chosen randomly from the data point and via methods like k-means plus plus. And this is necessary because k-means is iterative, it needs a starting point. So the another option, that is threshold on distances, it is not required. K-means does not require distance threshold to the from the cluster. Instead, clustered are from based on the nearest centroid assignment. So basically, they need the initial centroid point. And the stopping criteria is used, that is a maximum iteration, a change in the centroid position that should be less than that error, but that is not a user provided. This is a distance threshold that we are calculating. So it is also incorrect. No initial some initial parameters are required. That is a Number of clusters and initial cluster centroid. These two are required. Okay, that is option A and option C. So our next question is, are you expecting same clustering output for two separate runs of the k-means clustering? So can we expect the same clustering output for the two separate k-means clustering? Yes or no? From the two separate runs for the k-means clustering, can we expect the same type of output? It is not possible, no? Because they may have different centroids or different values itself. Okay, so here is the detailed solution. So in the k-means cluster, this is the following mini step, that is initialization. Select the key initial centroid, then assignment, where assign each data point to its nearest centroid, and then update it. Recompute the centroid as a mean of the assigned center, and it is repeat until it will converge. So what basically influence the final result? So k-means is sensitive to the initial choice of centroid, and different initialization can lead to different local minima, that is different crystal assignments also. It is always moving or varying from here to here till the final it will converge. So there are for the two separate runs, the different random initial centroid can produce a different output. Okay. So if when we will get the same output, if the initialization is fixed, that means using simple random state. If the data set has very distinct and well separated clusters, then even random initialization often converges to the same results. Okay. So the final answer is no. The output are not guaranteed to be the same for the two runs of the k-means due to random initialization of the centroid. So if the question is specify, if in the question it is given, it specifies that fixed initialization. That means fixed initialization is set, then answer could be S. Okay, so for the here the fixed initialization is not given. So answer is no. We cannot expect the same clustering output for the two separate runs. Okay, always remember. So now our next and final question is, match the two given attributes. We have to find out the match. So the clustering is given as a k-means mixture of Gaussian and mean set. The probability density function in estimation is also given in the next one, from which whom we need to just match. So non-parametric estimation of the PDF. Second one is parametric estimation of PDF. No explicit estimation of the PDF. So for K means we don't need any explicit estimation. We don't need the PDF, right? Probability density estimation. So for K means it is a 3. Now next one is the mixture of Gaussian. So parametric estimation of PDF is required, or means it, that is non-parametric estimation of the PDF. So here detailed solution is also given. So K means that is no explicit estimation of PDF is required. So that in the K means clustering, already we know that it is a centroid based algorithm that partition data into key cluster. It aims to minimize within a cluster sum of a square, but does not explicit model the or estimate the PDF probability density function of the data. Okay, the mixture of Gaussian, it is a parametric estimation of the PDF. That means so Gaussian mixture models (GMM) assume that the data is generated for the mixture of the several Gaussian distributions. It explicitly estimates the parameter, that is mean, covariance, mixing coefficients, and these Gaussian distributions, which are parametric form of PDF, the model of the data density. Now next one is a mean set, non-parametric. This is a non-parametric estimation of PDF. So mean set is a non-parametric clustering algorithm that identifies clusters by locating the models that is peak in the model density function. It uses the kernel density estimator to estimate the underlying PDF in a non-parametric way without assuming a specific functional from the density. So correct matches that means 1, that is K means that no explicit estimation of PDF, mixture of Gaussian parametric estimation of PDF, and means it is a non-parametric estimation. Okay, so for this one, mixture of Gaussian is parametric and means it is non-parametric. So K means 1 is 3, 2 is 2, and 3 is 1, right? So 1 is 3, 2 is 2, and so option D is the correct answer for this question. Okay, so I hope all of you understand these questions. So, and it will be the helpful to your assignment problems as well as to your upcoming exam questions also. It may be relatable to you. So, okay, now questions have been completed. If you have any doubt, you can ask. Otherwise, we can close this session. So, thank you everyone. Thank you for joining this session. Now, if
Thank
you
you so
have,
much, ma'am.
okay, thank you. Now, if you have any doubt, you can ask. Otherwise, we can close this session.
Thank you, ma'am. Thank you, good night.
Okay, thank you. Thank you.
Thank you, ma'am. Good night, Anjali.
Thank you,
Okay,
ma'am. Good night.
good night. Good night.
My daughters are your fans, ma'am. Actually, they have elder sister by name Pooja.
Oh, okay, 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 okay. Yeah,
So
okay, thank
they wish to always wish you. Thank you so
Oh,
much, ma'am.
okay. Okay, thank
Right.
you.
Good night.
Good night,
No,
good night.
okay. Good night, sis Sanjay. Good night, Pooja, sis Sanjay. Chepu.
Okay, now if you don't have any doubt, so you can leave the session. Okay, Swati, if any doubts are there, okay. So I am now closing this session. So I hope all of you have understand. So there